All right, so we're going to be going over, practice problem 1 for stormwater analysis. All right, so I have that problem right here. Going over it, we're going to use the rational formula to calculate the runoff for this proposed development. So what is the change? Remember, that's the pre-runoff minus the post-development runoff. It's an acre and a half, so let's annotate this a little bit. We have 1.5 acre site near Chicago University in Chicago, Illinois. It was forested, so that's important before construction. Post construction, we're going to be using or having a 50 by 35 foot coffee shop with a 100 by 120 parking lot. The remainder of the site is going to be planted with a lawn, and it's going to be well drained, sandy soil, has a slope over 7%. The design storm is 25-year, 1-hour storm, and it says use average runoff coefficients for the forested land and the post-development lawn, but use conservative values for the post-development roof and parking lot runoff. So spend some time talking about what that means. All right. And then remember to use the runoff coefficient adjustment factor for a recurrence interval greater than 10 years. All right, because it's 25-year. So to find the information about the amount of the storm value, we're going to need to go to this website right here, which when you go there, that's this website. And we just need to look up the location. So you go to Illinois. So click on Illinois. And then it's at Chicago University. So there's lots of different places to go. Easiest thing I think is to go to the station, scroll down until you see Chicago, and there's one for Chicago University. All right, it's going to take a little bit. All right, zoom in a couple times. And then, yep. So all right. So station is Chicago University. And there we have it. So we need the 25-year, 1-hour storm. So 25-year, 1-hour storm is 2.42. You see that number right here, kind of in the middle, top of the screen. So 2.42 inches per hour. All right. So we'll make a note of that. The 25-year, 1-hour storm, I is equal to 2.42 inches per hour. All right. All right. So we need to do pre-development and post-development. So I'm going to kind of split my paper into two here and do pre-development. Remember, the formula is Q equals CF CIA. All right. So for so we know A is 1.5 acres. Told us that in the problem. C sub F for 25-year is 1.1. If you go to the table and look at that. I we just looked up is 2.42 inches per hour. And then the last thing we need to do is look up the coefficients for the land. So you go here, and you need to look up the, let's see, it is the, oops, where am I going here? Yeah, it's going to take me a second to find the formula sheet. There we go. That's what we're looking for. So the formula sheet, if you scroll down, you'll find, where is it? Keep going, keep going. Here we go. Rational method runoff coefficient. All right, so just also to show you, so the 25-year storm, it's 1.1. And then for a forested area, it's anywhere between 0.059 and 0.2. So it did say in the instructions to use average. I use average runoff coefficients for the forested. So C is equal to 0.059 plus 0.2 over 2. That's how you take an average. When you plug that into the calculator, you get 0.129. All right, so Q is equal to CF CIA. So that's 1.1 times 0.129 times 2.42 times 1.5. All right, and when you do all that, you get 0.517 cubic feet per second. So that's our pre-development number. All right, post-development, I can give myself a little more room here. All right. Okay, so post-development, we still have C sub F being 1.1. We still have I being 2.42, but now we have a couple different areas. All right, so we have the coffee shop. We have parking lot. And we have grass area. All right, so the coffee shop we know is, if we can look at it, 50 by 35. 50 by 35. And that gives us 17,500 feet squared. Seems like a lot, but in terms of acres, when you divide by 40,560, you get that as 0.04 acres. All right. And then the parking lot is 100 by 120. Yep. 100 by 120. And that turns out to be 120, no, 12,000, sorry. Let's try that one. Okay. And divide that again by 43,560, and you get about 0.27 acres. And then the grass area is the remainder. So we started with 1.5 acres. We took away 0.04 for the coffee shop. We took away 0.27 for the parking lot. And so the remaining area is approximately 1.19 acres. Okay. So for the coffee shop, so that's A1. This is A2, and this is A3. For the coffee shop, we need a runoff coefficient. For the parking lot, we need a runoff coefficient. And for the grass area, we need a runoff coefficient. All right, so the coffee shop, if we look at the notes here, let's see, the coffee shop, we're going to go back here. And here we just kind of have to make kind of an assumption. It doesn't tell us exactly what the roof situation is going on, but since they didn't explicitly tell us that it was a what's it called, like a green roof or something like that, we're assuming kind of maybe worst case scenario, and that's what it means for conservative values, like worst case scenario, conservative values for post-development roof and parking lot runoff. So worst case scenario, meaning pretty much all the water runs off. It's going to be like a shingle type roof or an asphalt type roof. So worst case scenario is the 0.95. All right, you see that shingle roof, 0.95. Asphalt parking lot, 0.95. The worst case scenario, the higher the number, the worst case scenario. All right, so that's what it means to be conservative, is to be like, assume worst case scenario in this situation. 0.95, 0.95. All right, and then for the grass area, it did say we could use average values, right? So use average runoff for the forested and the post-development lawn. All right. So post-development lawn, it said well-drained, sandy soil, slope over 7%. Let's see, lawns, well-drained, sandy soil, slope over 7.7%. It's between 0.15 and 0.2, so again, an average there. So if we do that, it's 0.15 plus 0.2 over 2. The average of those two numbers is 0.175. All right. Let me just double check that. And yeah, 0.175, right? A halfway between 15 and 20 is 0.175. So to find the average C value, the composite runoff, we need to do a weighted average. So remember, that's where we have to do 0.04 times 0.95 plus 0.27 times 0.95 plus 1.19 times 0.175, all that divided by the total area. So it's area times runoff coefficient. So it was A1 times C1 plus A2 times C2 plus A3 times C3. So it's the area times the runoff coefficient for each one divided by the total area, and it's still an acre and a half. All right, so you do all that, and you type that into your calculator, so it's going to take me a second to do that. All right, so 0.04 plus 0.9, or sorry, not plus, 0.04 times 0.95 plus 0.27 times 0.95 plus 1.19 times 0.175, close my parentheses, divide by 1.5, and you should get somewhere around 0.335, which I'm going to round up to 0.34. And so now we have all the information we need. And so Q is equal to CFCIA, which is 1.1. And here it's C, the composite C, 0.34 times 2.42 times the area of 1.5. Do that multiplication, 1.1 times 0.34 times 2.42 times 1.5, and you get 1.35 cubic feet per second. All right, so now we have our two numbers. Our change in runoff, delta Q, is Q pre, oops, not pre minus post, post minus pre. So Q post minus Q pre, which is 1.35 cubic feet per second minus 0.517 cubic feet per second. So 1.35 minus 0.517, and you get 0.833 cubic feet per second. So we've increased by quite a bit. The increase is more than the original. So we have quite a bit more runoff. This would definitely need to be taken care of on site. So you need either some detention basins or some kind of system to control this runoff so it wouldn't flood a neighboring area. All right, so that's the basics of how you do something like this.